we're going to reverse the process. Now, instead of giving you the value of a random variable and asking you to find an area, I'm going to give you an area and ask you to find the corresponding value of the random variable. Okay?
Mm-hmm.
All right. So let's do that with our home run data. We want to find the distance of a home run that's at the 90th percentile. So remember, 90th percent, when we talk about percentiles, we're talking about area to the
Left.
So if we build our model, and notice every time I do a problem, I always build out this normal curve. Get in the habit of doing that. Okay?
Now I have a question.
Yes.
Why is it always to the left? Like
For percentiles?
Mm-hmm.
Because that's the definition of a percentile, is if you are at the 90th percentile, that means your particular observation is greater than 90% of all other values.
Right, and it can only go to 99.
You can only go to 99, that's true.
Right.
Mm-hmm.
So but it just always, you always look to the left for it then?
Always look to the area to the left with a percentile, because if you're at the 90th percentile, you're somewhere right around here.
Right.
And that means that particular home run distance is further than 90% of all other home runs.
Correct. Okay.
And so that means that we're looking for the value of X such that the area under the curve is 0.9.
Mm-hmm.
Okay.
Mm-hmm.
And so, here, let me type that out. In fact, we are looking for the home run distance such that the area under the normal curve is 0.90. Okie doke.
Sounds good.
So to do that, you're going to go back to StatCrunch. Our mean was 400.3, yes?
Yeah.
And our standard deviation was 25.6. We want the area to the left. We don't know the value of X. We're trying to figure that out. But we do know the area is going to be 0.9. You see how it's different here? I'm not putting in a value of the variable. I'm putting in an area.
Right.
You with me?
Yes.
Now when you hit compute, it's going to give you the value of X. So you click compute, and your value of X right there, 433.1.
Mm-hmm.
See it?
So that's essentially what you said is working backwards. So.
Yep. So
Okay.
this value of, are you still seeing it? Because I accidentally hit the pause button.
Where it's on the
Are you seeing me right?
Yeah.
the X equals 4.
Well, what it was, 400 what?
433, yeah. 433.
0.1, right? 433.1. So if your home run distance is 433.1 feet, it's at the 90th percentile. The diameter, the ball bearing one again, we want to determine the diameters of the ball bearings that make up the middle 99% of all diameters. Middle 99%. So we know this guy is 400.3, right? No, I'm on baseballs again. That's 1. And we want the middle 99%. So there's something here, some cutoff value. And there's a cutoff value here. I don't know this value. I'll call it X0. And I don't know this value either. I will call it X1. And the area in the middle is 0.99. So that's the area from here to there. Does that make sense?
Yeah.
So we
So
just
it's-
have to figure out the value of x0 and x1.
So real quick though, your one in the middle is slightly then to the right of the bar, or because
No, it's this bar. This one is underneath the vertical bar. That's the mean.
and then the 0.99 is also the bar then, or
No, that's the area under the curve between x0 and x1.
okay. Oh,
Okay.
okay, I got you now.
And then what that implies, by the way, is that this area is going to be 0.005 and that area is going to be 0.005.
Gotcha. So you're incorporating it all to about those little points that you put in.
Yes.
Okay.
Yes. Sound good?
Yep.
Mm-hmm.
So now we're going to go to StatCrunch to find the value of x0 and x1. Our mean is 1. Our standard deviation, what was it, 0.005?
Yes.
And I think this works. If I click between and then leave these two guys blank and just put in 0.99 here, like that, you with me?
Mm-hmm.
When I click compute, bada bing, it gives me those two values.
Nice.
Okay, so you do put it in between and not standard, you're saying.
Right.
Okay.
Yeah. Now, if you did do standard, you'd have to make adjustments.
I see.
You'd want the area to the left is 0.005 like I did. And there's that 0.987,
Right.
right? And then what you'd want is either 0.995 to the left to get the right bound, or if you made this a greater than, put in 0.005 to the right.
Okay, so
But
they
that's a
can both
boatload
give
of
you
work.
right. They both give you the same answer. But
Yeah, I think picking between and just making that 0.99 and clicking compute gives you the value.
okay.
Pretty
Yeah,
slick,
a lot easier.
Easier. Yeah. So the ball bearings that make up the middle 99% are between 0.987 centimeters and 1.013 centimeters. Yes?
Uh-huh.
Uh-huh.
There you have it.